Okay, fine. Today we will have a deep understanding for the method. So let's taking a look of the opening problem. Like suppose we have a problem that is to find the sum of the integers from 1 to 10, from 20 to 30, and from 35 to 45 respectively. That means the problem has 3 parts. And the 3 parts is some integers, right? They are similar, just the range is different. So how can we do that? We can do in such a way. Here, I can write today. Here for the first part, we're using the for loop from the I is equal to 1 and the end by the I is smaller and equal to 10. That is the range for the first part, that is 1 to 10, right? So we sum them together and then we get the result. And for the second part, we do the same thing. We reinitialize the sum. We set it to be 0. That means we restart, right? And once we restart, we set the I is starting from 20 and end by 30. So this range is 20 to 30. And we sum them. And then we get output. And same thing happened for the third part, which is from the range of 35 to 45. And this is the third part, right? We also initialize the sum. And we're also using the for loop, and we're using the same sum plus equal to I to aggregate them, right? And after that, we system output lane the summation for the problem. So let's take a look of what the similar of the these three parts. For example, here, okay, I think I should change one. Using the highlighter. Here, we always have a sum, right? The first one, we have a sum. The second one, we have a sum. The third one, we also have a sum. This is the first thing that's shared by the 3 parts, right? So what is the next thing? Let me change the color. And both of them using a for loop, right? For something, the for clause. And even inside, it initializes the I to be something, and I should suppose smaller and equal to something, right? And after each iteration, I is incremental by 1. So they are same. I'm highlighted them using the green. And inside the for loop, they also share something same, right? Both of them using the sum plus equal to I. This is the same. What else? How about the print message? It seems they are also similar. We say, let's using the purple. The same system out print link, right? Sum from where to where is something. And here they are also the same. System print out link is the same. Sum from to is plus sum, right? The commands, they are same. The only different is the number. So in this case, can we, making a template for the 3 parts of the summation? The answer is yes. Let's taking a look. So since they are similar in a specific way, so we can abstract the logic of the summation into a method. Let's overlook of the solution of the method For example, here, it declared it to be a public static method. However, in the future, we will get into some more method types. And this is the, okay, let me change for the pen. This is the method name it gives it. Method name. Hey, sorry. It seems that I touched anywhere. Okay. And then we have a parameters here. One is I1, the other one is I2. So it means that in this method, we have two parameters to tackle with. The first one is I1, the second one is I2. Those are, you can take them as a placeholder. Quite weird. Sorry. What's the problem with it? For different integers. And the I1 and I2, you can take in them as the range, I1 and I2. Okay, it says that, I think now it's sharing and it's paused. Okay, let me reshare it. I don't know what happened, but okay, I1 and I2. So in this case, we're using a sum here to represent the summation of the integers, the result from the I1 plus I until I2. And we use I1 and I2 to be the lower bound and the upper bound in the for clause here. Here it writes it using the I1 to initialize the I and using the I2 as the termination. Here it means the sum is equal to I1 plus something, something, something until I2. So this is a range. And then it returns a sum. Once it returns sum, in the void main method, we can call this is the method name, right? This is the method name. I think I should change a color. The method name corresponding to here. And we pass different I1 and I2 into this method. So in this case, it will automatically return the sum because we have the return code here. And also this is the type, return type there. So in the print information, it will automatically print the summation from 1 to 10. And that is the method we are talking about. It's more like a template to do something. So let's have a definition for methods. A method is called a collection of statements that are grouped together to perform an operation. Like here, you have something, the accessors and the statics. Those are keywords, and this is the return type. This is the method name, and this is our parameters here. And how can we invoke a method? Here is the way. We invoke it using the method name, right? They are the same. And we pass the actual parameters into the method we are invoking. Here, it refers to the x, y, and that means we will pass the x, y to the number 1 and number 2 directly. And in this case, the x, y will the number 1 will be replaced by y and number 2 will be replaced by y. as long as the method has the real value for x and y, which is referring to the original number 1 and number 2, and it can get the calculation and then get the result. And here the number 1 will be go as x, and the number 2 will be replaced by y. And here it's the same, because when executing, the actual parameters will take place of the original number 1 and number 2 in the method. Then we will introduce the keyword in the method. The method header is the first line. So the public static, they are the modifiers. And the second one, integer, it's really important because it's referring to the return type. If this method is not void, that means it should return something which is at the end of the line responding to it. That means the result should be an integer. And we have our method name after the return type, that is the max. And after the max, we should have the parameter list. That is the integer, int number 1 and int number 2. Those are formal parameters. And when this method is executing, the actual parameters will take place the formal parameters. And we also say that the int number 1 and int number 2 are method signatures. Let me highlight it. These are method signatures. So you have to remember what are those elements in the method headers. It is a requirement for you to memorize them. And after the first line, which referring to the method head, after that, it is a curly brackets, right? And between the two curly brackets, which is here, oh, sorry. Let me get back. Eraser. Here and here. Between the two curly brackets, they are the method bodies. This is the overall logic to implement our method. So in this case, we have our definition for the methods. And the method signatures, which is highlighted here in red, the int number 1 and the int number 2, they are the combination of method name and the method parameter lists. And the variables defined in the method header are known as the formal parameters. Well, you have to distinguish what is the these are the formal. Let me change the color. These are formal parameters. However, when the code is actually doing something, the formal parameters will be replaced by the actual parameters. Because in the method, it's a template there, which is using something concrete to execute this method. And here it says that when the method is invoked, you pass the value to the parameter. This value is referred to as actual parameters or argument. And for the return type, a method may return a value. The return value type is the data type of the value the method returns. We just have highlighted that if the return type is a specific type. Here it is int. What we have to return, like here, the result here is supposed to be the same thing. Because if you are requiring the program giving you an integer, if it is giving you a floating point number, that means the program is going wrong. However, if the method doesn't return a value, the method return type is in the keyword void. We have some void method in the setter method, right? Suppose we want to set the name for our account. Usually in that set method, we don't have the return type. It seems like we write something like public void, right? Void set name, right? We have a parameter string, something like string s, and then we have something like, okay, this dot name is equal to s. And once we have finished this line of code, we using the other curly break to end this block. We don't have the return, right? We don't have this one. So that's the difference for the void method and a method with the return value type. Okay, let's having a look over the example. I'd like to using the online version, so give me a minute to switch. Okay, here we have a test max program. Here, the method is defined here. So let's do the animation. So the program starts the execution from the main method. This is PSVM we set, right? So we declare the integer I. We assign the 5 to the variable I, and then we assign the 2 to the variable J. And then this statement invokes the max method and assign the return value from the method to K. So after we execute this line of code, the cursor will move to the line 12 because here we are going to invoke the max method. Let's see. Okay, note that in all code animation, you can use mouse finger to highlight the explanation output. Check your understanding box freely. Is the value I passed to number 1 when invoking max I, J? Answer yes or no. I say yes. Let's try. Okay, you are correct. That means when the max method is invoked, the value 5 will pass to the max method. Then let's continue. Now, as you can see, the value I and J are passed to the number 1 and number 2 in the line 12. After that, we declare a variable that is result. And then we write a if-else statement to make comparison to get the max number. If the number 1 is over number 2, here it means if the 5 is over 2, we will assign the number 1 to the result. So the result currently is 5. And after that, we will return the result. As we can see here in the stack, the result has the value of 5. So here we will return the 5 to the line 6. That means K now is to be 6. As you can see, the K now is to be 5 in line 6. As you can see in the value in the memory. After we have our K, we display the result. And once we reach the curly brackets in the main method, and the program is finished. And that is for this problem. So let's get back to the slides. We are just having a demo for it, so we will not look into the slides detail. Okay, here it says that a return statement is required for a value returning method. The method shown below in A, which is referring to the left block, is logically correct, but it has a compilation error because the Java compiler thinks it's possible that this method doesn't return any value. And it should be written in the B block's way. That means we have to delete the n is smaller than 0 in A, so that the compiler will see a return statement to be reached, regardless how the if statement is evaluated. But let's see what's happening in the A. Here it's declared a method. The method name here is sign. Okay, let's review. This is the method name, right? This is the formal parameters, right? Integer n. And both here, we say they are the signature, method signature. If you still cannot memorize it, it's fine. Just follow me. So before the signatures, we can see that we have we have a keyword int here. That means the return type is integer, right? Return type. And in the main body, in the method body, that it says that if n is over 0, it returns 1. Else, if n is equal to 0, it returns 0. Else, if n smaller than 0, it returns -1. Okay, that means the problem is lines in the if-else statement, because in the last one of the if-else statement, we do not include any condition because it's a fallback. We say fallback. So we just need to remove this line. So that means if the n is not matching to the first two conditions, we say these two conditions, and then it will go to the, everything will go to the else return -1. I don't think it is a big problem, but just remember it. It's fine. It's enough. Okay, here is the call stacks for the main method. Actually, it is not very important because as this is the first course of your Java programming, and actually this should be learned in the computer systems or computer architectures when you are getting higher level course. But we will have some touch it pretty shallow. And I will explain it in, I will try to explain it, but if you cannot understand, it's totally fine. So when we are invoking a method, actually we are calling stacks. That means in the main method, we have the k, j, I is stored in the memory. However, when the main method is invoked the max method here, This is for the main method. As we can see, this is the main method. It's a frame. This is a frame for the main method. And then when we are calling the max, there will be another frame here for the max. Here they will pass the actual value. We say this is the actual parameters, right? We say this number 2 and number 1, they are formal parameters. When the main method is calling the max method, the actual parameters will pass to the max method for the formal parameters. That means the number 2 will be take place by the 2 and the number 1 will take place by the 5. And once the 2 and 5 was set, right here set, the result here will doing the logic and make comparisons. Once make the comparisons, the program will know what is the value for the result. And since this is a return type method, the block, we say the max method, the green block will return the value which we specified at the last line of the max method to the main. This is the main. This is the main frame. And then this one will return to K. Because we say that what we invoke is K is equal to max to 5, right? So the result is 5. So K is to be 5 now. And once the main method is finished, the stack is empty. That means the program has been ended. And that is the call stacks and the internal status for this method. Okay, let's see whether we have the animation for the call stack. Okay, actually the online website, they don't provide the animation, so we will go through the slides to visualize how the stack is changing. Okay, I think the screen is sharing now. Okay, here we firstly in the main method, we declare I and we assign 5 to it, right? So here in the stack, it is I, a comma. After that is the value for the I. And then we declare the J and we assign the value 2 to J. And after that, we declare a K. However, K currently is referring to a method that is the max ij, right? Referring to the downside block of the method. Here, we invoke the max ij. And we say that if we are calling a method, a new frame will come into our stack, right? So here, and the max is coming. Actually, it doesn't show, but I would like to write Here is the main method, and above is the max method. And as we have shown in the previous slide that this is the actual arguments, right? Actual arguments will pass to the formal arguments. So that means 5 is assigning to the number 1 and 2 is assigning to the number 2 here. And after that, inside the max method, we declare a variable that is named result. It's okay. And once we declared everything, we make the comparisons. In the if-else statement, we compare the number 1 and number 2, which is referring to the 2 and the 5. And here, the number 1 over number 2 is valid because 5 is over 2. So the result is getting the value of the number 1, which is the 5. Once we have our 5, the max method returning the 5 to the main method k. As we can see here, the result is returning from the max method to the main method. And once we have done the assigning, we print out the statement of the max number between I and j is k. So k is 5, is printed. And that is the call stack for these two methods. And one thing I have to mention that for the stack, in the future, you may study something about the computer system. In the computer systems, you may know the difference for stack and for heap. Currently, it's not a requirement, but it's better to know something about it. For stack, it is some container. You can think it as a container. The first thing get into it will be the last one get out, because there is a bottom. Stop it to get out here, right? No, what it can be grow. The growth direction is up. So that means here, this is the line y. I is created first. So I is in the bottom. Since we cannot go through the downside, because this is already the bottom. So when we are declaring j is the second. So j would be stacked upon the I. So that is the second place. And that is the same for the k. Which means that the earlier you declare something in the stack, the bottom, the earlier things should be placed. And that is the stack. For heap is a little bit different. Heap is going downside. But currently we are not dealing with heap, so we will not touch it. And let's take a look over the passing parameters here. We have our modifiers, that is the public, static, void. And let's record. Let's record, okay? Because today you are the first time learning the deep something of the method. So let's record. What is this? We say the unprint lane string message or the int n. They are the method signature, right? The name with the parameters. These two things together making the method signature. And here we have a string message and we have an integer in passed to it. And inside the method body, it's a for loop. For I is equal to 0 and I smaller than the n, we will print the message. And each time after the message printed out, the I will plus plus. That means I incremented by 1. So what does it mean? Let's have a try. Like, suppose we invoke this message. That means the message currently is equal to welcome to Java, right? And the int n is equal to 5. So in this case, we pass these two things to the method. And then let's have a look over the inside for loop. Here it says for integer I is equal to 0, I is smaller than n. Here n is 5, right? And we should system print out the message. The message is welcome, da 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 da, right? And then once we have done with it, suppose this is our terminal. We will have a message, welcome to Java. Okay, once we have done with the first print out message, the I will increase by 1, and it will be from the 0 to 1, right? So 1 is still smaller than 5. That means we still have to execute the method body, the for loop. We still have to execute the system.out.println message. And that means we will have to write another welcome to Java again. And after that, the I1 will increment from 1 to 2. And 2 is still smaller than 5, right? We still have to execute the for loop body. So in this case, another welcome is going to be executed. And everything repeated until the I incremented from 2 to 3 to 4 to 5. Until to 5, it finds out that, oh, 5 is equal to 5. And then the for loop will not be executed. So in this case, that means when I is equal to 1, 0, 1, 2, 3, 4, that means there are 5 iterations, right? That means in our terminal, there will be 5 messages. Welcome to our Java. And this is the passing parameters for this case. Here, we passing a string type and an integer at the same time to the unprintln method here. So in the second example, suppose you invoke the method using unprintln computer science and the 15. That means you're passing the message as computer science. So what you will have to change is just change the welcome to Java to computer science. And in the first example, they are 5 times. However, in the computer science scenarios, the terminal, there should be 15 computer science there. And same thing, let's taking a looking at the third example. Here it says imprint 15 computer science. Okay, this is pretty important. As you can see, the position for the 15 and the computer, they have exchanged, right? As we can see, if we want passing the parameters, as we can see in this slide, the I is passing to the first parameter, the J is passing to the second parameter. That means the sequence, the order of the parameters really counts. We cannot exchange them because we are passing the first to the first, the second to the second. So let's thinking, if I pass 15 to the unprintln method, the first place is a string type. However, 15 is an integer. So in this case, this one will give you an error message. Error. how to spell it. Okay, you may know it. So in this case, the error message will indicating something and making you the program cannot working. So please be sure that when you are passing the values, the order of the parameters is really important. Don't mix them and don't making them in a mess. And it is another example. It is example to change the number 1 and the number 2. But here we don't have the samples, so we will not talking about it because it is the same thing for the max. And here we are also talking something about the overloading. So overloading, that means the method name is the same, but the parameters types are different. They can be appeared in the same program. It is allowed. That means if you pass something different, the program will using the pattern matching mechanism to find out the according method for you. Suppose here, what we have changed? We changed the number 1 and number 2 to be a double. And the return type is also changed into double. We previously using the integer, right? Int. However, here we're using the double. These two things can be appeared in the same program and we can still run. However, it sometimes invokes the ambiguity. Let's take a look. Here we say sometimes there may be 2 or more possible matches for an invocation of a method, but the compiler cannot determine the most specific match. This is referred to as ambiguous invocation. And an ambiguous invocation is a compiler error. But sometimes it still can working. Just the result may not so correct. Let's see this example. First, it declared a main method. It's supposed to print out the max between the 1 and the 2, right? And we have the 2 max method. The first one is a double max. Okay, let me using the highlighter. I want to change the color for it. Using the orange. The max is the same. Return type is the same. What makes them different? The first one in the parameter list, it is integer, right? And then it is double. However, in the second one, the first is double. And the second one is int. I mean, the order of the data type, the parameter type are exchanged. So what will happen? I don't know. It depends on the number 1 and number 2. Actually, in this case, I don't think it will matter. Because the integer will be upgraded to double automatically by the compiler. Actually, in the modern compiler, they have some mechanisms to tackle with such scenario. So usually you shouldn't worry about that, but it's not a good habit to write such a thing. If you want to make them making comparisons and making them more specifically, you should not making 2 method within using the sharing the same name. It's not good to do so. Although it is can run, but well, they can run. It's not a good habit. So if I were you, I will delete one of it. Like I may not using this one. I only keep the upper one. And then let's talk something about the scope of the local variables. We have touched some of the local variables previously. I'm not talking it's too much about it. At that time, I'm pretty sorry for it because that is Java. When you are starting Java, when you are getting started to learn Java, you have to learn something. You may not currently, no need to, haven't started. Maybe you are at the chapter 3. However, some knowledge is in the chapter 11 and chapter 12. What you have to do is just memorize. Until you go to the chapter 11, you will find out, oh, that is such a thing. And that is Java. So it's sometimes it's a little bit difficult for the learners to understand Java. But it's okay. We can try, right? We can make every problem, we can solve it as long as we keep doing it, keep studying. All right, let's have a look over the slide. What is a local variable? A local variable is defined inside a method. What is a method? A method is a collection of the code, right? A collection of codes in between curly brackets, right? After the method name. And the scope is the part of the program where the variables can be referenced. The scope of the local variables starts from its declaration and continues to the end of the block that contains the variable. A local variable must be declared before it can be used. Okay, that means that what it means that, okay, this is the scope. And what you can do is within what's the variable is valid is only in this scope. Out of this scope, the local variables will become turning to invalid. And you cannot using the invalid variables outside of the scope. And you can declare a local variable with the same name multiple times in different non-nesting blocks in a method, but you cannot declare a local variable twice in nested blocks. Okay, it's a little bit, I mean, the word is too not friendly to our mouse, but let me using an example for it. Suppose we have a method here, right? Yeah. We have a method. This is the parameter. Okay, this is the scope for the method. And we may have some inside method, nested method or nested block. Okay, I currently I may not know what of them, but I will using another curly brackets to indicate. Suppose I have I is equal to 1 here, right? Can I declare another I is equal to 3? This is not correct because if you declare the same thing here, only this is valid and this will be removed. I mean, be replaced. However, you can always declare another I inside the red block. Suppose here is another I, we say it is 5. Okay, it is allowed because they are in the different block. That is what this slide is talking about. And you may ask that, oh, in this method, there will be 2 I. Yes. Are the 2 I refer to the same memory address? No. So I may touch something a little bit far from our course. That means in our memory. Here is an I, which may be referred to this one. However, in another place, this I is stored here. So that's making the two I together. The thing is, if the two I is declaring in the same block, for example here, all these things is referring to this block. That's why initially it is 1, right? And then in the second time, the I becoming 3, and the 1 is override by the 3. So that makes the first line of I is equal to 1 invalid. A variable declared in the initial action part of a for loop header has its scope in the entire loop. But a variable declared inside a for loop body has its scope limited in the loop body from its declaration to the end of the block that contains the variable. Let's look at the figure. For example, the I is declared in the for clause there, right? So the I is valid from the first line within this. I'll change a highlighter. So I is valid from this line, 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 until here. This is I. However, for J, since J is only declared here, right? So its valid it is only valid after its declaration. So for J, it's valid here, valid here, valid here, valid here, valid here. However, it doesn't valid before the line here. So that is what it's talking about, the scope and its validity. Okay, this is also talking something about the nested loop. He says that it is fine to declare I in two non-nested blocks. As we can see, the first block, we have an I. The second block, we still have an I. That's because they are belonging to different blocks. And it is wrong to declare I in two nested blocks. The first block is there is an I there. However, in the nested block, there is another I there. It is wrong. But sometimes I'm thinking it is correct. Oh, in this example, it's not correct. Because the for loop can be regarded as one line of code. It is not a block. It is a for loop. A loop is not a certain kind of thing. However, if we adding a block, for example, if we adding a block individually using such a thing, that means this scope has been taken out. So in this scenario, it is valid. This one has a big power. The curly brackets. It can okay. It can taking out a specific piece of code and redeclare the scope for the variable. If I suggest you, if you are still cannot understand it, just writing code. Like you write the left code and write the the right code, implement it and run it, and you will have a sense of the scope notion. Okay, let's have a look over this error code there. Oh, fine, with no error. This is not error. Let's see. Here it declared the first integer x and y, and then in the for loop, they use the I there, and they're using the I to increment the x. And in the second line, since the first for loop and the second for loop, they are different for loops. They are in the different area. So I can be reused. It is allowed. But what if I declare an integer I is equal to 1 here? Okay, this is not correct. Because the I has some conflicts after that. Okay, this is with errors. Where is the errors? X1, Y1. Okay, this is because actually I don't think it's an error because we don't know what is the method is going to do. If we don't keep the X outside there, it may be correct. So we have to ask the intention for this method. But here, as long as it says it's incorrect, okay, it's fine. As if you are in the exam, the problem statement would be much clearer. All right, here is the method abstraction, like we just introduced in the beginning of the course, that a problem may ask you to summation a certain range of integers, like from 1 to 10, 20 to 25, or 30 to 50. So in this case, you may using a specific method to do it rather than writing 3 pieces of code, right? So you can thinking of the method body as a black box that contains the detailed implementation for the method. So you will have a method header and there's arguments and the return types. And this is what we call method abstraction. The benefits of method is you may write a method once and reuse it anyway, like the examples we just mentioned, the 3 pieces. You may write the method abstraction, and each time when you want to aggregate something, you just call the method, change the formal parameters into the real parameters, and then the program can be execute the method automatically. And you do not need to write the repeated code by yourself. And also there are some benefits. We call that is information hiding, hide the implementation from the users. That means when you are doing a project, sometimes for making the code is easy to read, we may only need to know the method name. We say it is an API. And once we know the API and we know what it is going to do, we no longer need to implement the details, right? Because maybe we call the Python library or something. The details is already existed in the library. What I have to do is just finding out the API, the name for the method, and it's done. It is information hiding. And for some open sourced programs, right, you can not finding the implementation details because everything is wrapped into the method, and you don't know how they implement their program. What you know is just read their manual, and then understand how to using the APIs they provided. So another benefit is reduce the complexity. You don't create anything. You just borrow their others' knowledge and use it. And let's take a look of this case study, generating random characters. Like the computer programs process numerical data and characters. You have seen many examples that involve numerical data. It is also important to understand characters and how to process them. As introduced in section 2.9, this is chapter 2, we always got something about the characters has a unique code, right? Between 0 and FFF. And when we are talking about the unit code, we also talked something about the ASCII code. Okay, but they are none of the business with our course now. So to generate a random characters is to generate a random integers between 0 and 65,535, because these integers is represented for the characters themselves using the Unicode. And then we using the Unicode to following the expressions that, like we call the method math.random. This is a method call. And then plus multiply by the 65,000 something plus 1. And after that, we using, as you can see, we using the what we say that this is a type conversion, right? And we get the numbers for it. Actually, the characters in the memory, they are stored in numbers type. Everything is number. And even the number itself are stored as the bit code. We say bit stream. So actually in the systems, everything looks the same. Looks similar, not same, because 0, 1, 0, 1 is different from 1, 1, 1, 1. Okay, we will skip off this random thing. And let's taking a look of the random the example, because examples is much clearer than we are talking. So let me check whether we can play it online. Random characters, right? Random character. Okay, great. We have this example online. Here is the class for our random characters. In the first block, we have the get random characters, this method. Here we have char1 and char2, and we put them into this method, and then we return a specific random thing. You know that since it is random, so you cannot control what the things should be returned. And the second one is generate a random lowercase letter. And the parameters is void. That means we don't need to pass anything to it. But once we call this method, we will get a random characters from A to Z, which is the lowercase for A and lowercase for Z. And the third one is to randomly get the uppercase letter A and Z. The fourth one is to get the random digit character from 0 to 9. And also for the Unicode, or maybe we say the special symbols, we're using the Unicode \U with 40 to the \U for 5. This is the definition for the random characters. And then let's test the random characters. Here, we declare the number of chars is 175 and chars per line is 25. That means it seems that this method is going to create something that is, I don't know, let's try, okay? It declares two constants. For the for loop, it initialized I is to be 0 until I reach the number of chars. That means for the outer loop, it will have 175 iterations. So what is the loop body? The loop body, they invoke the method to generate a random lowercase h. If the lowercase h mode, the chars per line is 0, that means if the I is chars per line, okay, that means that means only when the I plus 1 is equal to 25, at this time it can be equal to 0. And then we will output the char. However, the CH is a random generated characters. So here that means it may be in the 175 times. Only a specific times it will output the H, output a specific characters randomly. So let's run it then. Only when the I plus 1 mode, the char per line, that is 105 mode 25. What is the value for it? Let me check. It seems that it controls the number of characters it's supposed to be generated. Okay, 135 mode divided by 25 is 7. That means only 7 characters is randomly generated. Here we already have 6 characters, so there's supposed to be 1 more characters. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm wrong now. I plus 1. Oh, that means, it is not counting the number. It means that within the 175, if there is a certain kind of constant and such constant, so 25 is divisor. So in this case, it will output a random characters. So the number of the random characters is divisors times. Okay, I will not implement this program because 175 times is too much. You may try to play with it, and the link is in the content, and then you click the other resource, and you will find another tab that is supplemental, and here is the link, like examples from Introduction to Java Programming, and you can open it in the new window. and then you can find all the online demos there. For this example, it's in the chapter 6. Just click the test random characters and then you can visualize the steps one by one. Okay, let's get back to the slides. Design diagrams. Let me check. Actually, in the later slides, those are example demos, but I don't want to keep you to watch me to show those demos because you can find them through online. So our course is almost is ending here. Next, for the next class, we will review our course from the chapter 4 to chapter 7. And please do come and open your camera next week because there is an observer there. And after the spring recess, we will have our exam too. I think you have enough time to review and implement the code. But don't worry, the exam 2 is almost following the same logic with the exam 1. And that's it. Thank you for everybody. If you have any questions, you can stay. Otherwise, you can leave.
Have a good one, Professor.
You too. Have a good night. Sorry, I didn't receive email. Recently, they are changing emails, so I cannot. Are you submitting to the Brightspace or my email? I didn't receive your email. Oh,
Professor,
then
I have a question.
yeah,
For the chapter, I see there's a chapter 1 assignment
yeah.
that's due today
Oh, due today? I can extend. Wait a moment.
because I was just double checking. Because I see the
Oh
previous
yeah, yeah.
answers are there, if I'm not
Um,
mistaken.
she doesn't actually want you to do the homework for it, from what I've
Oh,
she like okay, I've had this question a bunch of times. What the professor wants is like if you had any problems with it, note it down, like put it in like the area, put any notes that you thought about the homework or any stuff like that. You don't need any
Y-
answers.
Yeah,
oh,
yeah,
okay.
yeah.
Yeah, copy. All right, thank you.
Okay, okay. I will
Thank you,
extend all
Professor.
the homework for you. Don't worry.
Thank you, Professor.
Yeah. Oh, oh, I saw Julie's homework extension. No problem. I will extend all the homework for you after until the last day of our course. No problem. No problem. No problem. I will extend all the thing.
Are you extending the debugger as well, or I was just curious. I have the time if you don't, but I was just wondering.
Oh, for what?
The debugger homework or just or no?
Do you know how to debug?
Yeah, yeah, yeah. I need to see if I can open the Java thing, but okay, I actually can. Okay, perfect. Yeah, I can do it. It should be fine.
If you don't know, you can come to me.
Okay.
Do you need help? Okay.
Okay. Thank you, Professor. Have a good day.
Okay, okay, okay.
I'll let
Let
you know
me.
if I need an extension, or I'll email you if I need an extension for that one homework for the debugging one.
Okay, no problem.
Okay, thank you.
I
Have a
will
good day.
extend it. Don't worry, I will extend it. But for that one, I will not extend to the last day. I maybe next month. It's fine.
I mean, that's whatever works with you. I can do it. I just been like I've been doing like other homeworks, or I've been trying to read through the chapters and stuff. 'Cause I know we're gonna have our exam too soon, I think.
Okay, 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 okay. No problem.
Okay, thank you,
If you
Professor.
even if you miss something, even you miss the exam or something, just let me know. It's fine. It's fine. I can reopen everything for you.
Okay, thank you.
Bye.
Okay, bye.